Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of blockchain technologies. We'll dive into key concepts like channels, transaction validation, writing smart contract using Hyperledger Fabric, writing smart contract using Ethereum, overview of Ripple and Corda. Let's get started. Slide 1. Channels. What are channels? Channels in blockchain are private subnetworks. Think of them as separate meeting rooms within a large building, only specific people are allowed inside. In blockchain, these are used to create a private space for certain participants to exchange information or transactions without others in the network being able to see or interfere. Key points to explain. Privacy. Channels ensure that sensitive information stays visible only to the intended parties. For example, in a supply chain network, a manufacturer and supplier can use a private channel to negotiate prices without other members accessing this data. Scalability. By dividing the network into channels, each channel handles fewer transactions, which improves overall network performance. Data isolation. Unlike a public blockchain where all data is visible to everyone, channels help isolate data. This is particularly useful in industries like healthcare or finance where confidentiality is crucial. Real-world use. Hyperledger Fabric uses channels extensively. When a network participant joins, they can be added to specific channels based on their role or involvement. Why are channels important? They strike a balance between the transparency of blockchain and the privacy required in enterprise use cases. Slide 2. Transaction validation. What is transaction validation? Before any transaction is added to a blockchain, it must be checked against certain rules. This process is called transaction validation, ensuring that all transactions are legitimate, accurate, and secure. Key points to expand on. Endorsement policies. These are rules that define which participants must approve a transaction. For example, in a consortium of 5 banks, 3 banks might need to approve a transaction for it to be valid. Consensus mechanisms. Explain briefly how methods like proof of work (POW) and proof of stake (POS) achieve agreement across the network. For Bitcoin, POW requires solving complex mathematical puzzles. Orderer's role. The order ensures all transactions are sequenced correctly before they are validated. This prevents conflicts like double spending. Integrity checks. Highlight how cryptographic hashing ensures that the transaction data hasn't been tampered with. Example, in Bitcoin, miners validate transactions by solving a cryptographic puzzle (POW). This process ensures the transaction is legitimate and prevents fraudulent activity. Why is this important? Validation is the backbone of blockchain security. Without it, the ledger would be vulnerable to tampering and fraud. Slide 3. Writing smart contracts in Hyperledger Fabric. What are smart contracts? Smart contracts are self-executing programs that automatically enforce the rules and terms of an agreement. In Hyperledger Fabric, these are referred to as chain code. Key points to explain. Languages. Hyperledger supports multiple programming languages like Go and JavaScript, making it easier for developers to write smart contracts. Role-based access. You can restrict who can execute certain parts of a smart contract. For instance, only an admin might be allowed to update contract terms. State management. Every smart contract keeps track of the current state of the blockchain, like an inventory system that updates quantities after each sale. Lifecycle policies. These govern how smart contracts are installed, updated, or deleted. Example, automating payment release after goods delivery in a supply chain. Why is this important? Smart contracts eliminate the need for intermediaries, speeding up processes and reducing costs. Slide 4. Writing smart contracts in Ethereum. How are Ethereum smart contracts different? Ethereum smart contracts are highly flexible and run on its decentralized network, powered by the Ethereum Virtual Machine (EVM). Key points to discuss. Solidity. This is Ethereum's native programming language. It's specifically designed for writing secure and complex smart contracts. EVM. Explain how the EVM ensures that smart contracts execute the same way on every node in the network. Gas fees. Discuss the concept of gas, a fee for executing smart contracts. It's a crucial part of Ethereum's ecosystem but can lead to high costs during congestion. Interoperability. Ethereum's ERC standards, like ERC20 for tokens, make it easier to create interoperable applications. Example: a crowdfunding campaign where funds are automatically refunded if the target amount isn't met. Why is this important? Ethereum's smart contracts power decentralized applications, DApps, and drive innovation in areas like DeFi. Slide 5. Overview of Ripple. What is Ripple? Ripple is designed for fast, cross-border payment processing. Unlike Bitcoin, it's not just a cryptocurrency, it's a payment protocol. Key points to highlight. Native token, XRP, used to facilitate quick and cost-effective transactions. Consensus protocol. Ripple doesn't use mining. Instead, it has a unique consensus mechanism. Interledger protocol enables interoperability between different payment systems. Low latency. Transactions are processed in seconds. Example: Ripple helps banks like Santander handle international transfers in seconds. Why is this important? Ripple modernizes global finance, making payments faster and cheaper. Slide 6. Overview of Corda. What makes Corda unique? Corda focuses on privacy and secure transactions for businesses. Key points to explain. Permissioned network. Participation is restricted to verified entities. Privacy features. Only relevant parties can access transaction data. Notaries. Validate transactions to ensure consistency. Enterprise integration. Works seamlessly with existing business systems. Example: used by banks to automate and secure loan approvals. Why is this important? Corda's tailored approach makes it ideal for industries like finance and healthcare where privacy is critical. Slide 7. Advantages of Hyperledger Fabric. What makes Hyperledger Fabric stand out? Hyperledger Fabric is a permissioned blockchain framework designed for enterprise applications. Key points to highlight. Permissioned access ensures that only authorized participants can join the network, which improves security. Customizable architecture. Its modular design allows users to adapt the framework to specific industry needs. Data privacy. Channels and access controls protect sensitive information. High performance, optimized for enterprise-level scalability and transaction throughput. Interoperability, easily integrates with existing enterprise systems. Example: a supply chain application where only relevant partners can view transaction details. Why is this important? Hyperledger Fabric's flexibility and security make it suitable for industries requiring robust, private blockchain solutions. Slide 8. Disadvantages of Hyperledger Fabric. What are its limitations? While Hyperledger Fabric is powerful, it's not without challenges. Key points to discuss. Complex setup. Requires technical expertise to configure and deploy. Costly implementation. Infrastructure and maintenance can be expensive. Learning curve. Understanding Fabric's architecture and tools takes time. Limited decentralization. As a permissioned blockchain, it's less decentralized than public blockchains like Bitcoin. Resource intensive. Needs substantial computational resources for optimal performance. Example: setting up a network for an international supply chain involves configuring multiple nodes, channels, and policies. Why is this important? Understanding these limitations helps businesses decide if Hyperledger Fabric is the right solution for their needs. Slide 9. Advantages of Ethereum. Why is Ethereum popular? Ethereum's flexibility and broad use cases make it a leading blockchain platform. Key points to highlight. Decentralized Applications (DApps) supports a wide range of applications beyond cryptocurrency. Smart contract functionality automates processes and eliminates intermediaries. Active community. A large developer community ensures continuous innovation. Interoperability. Standards like ERC20 and ERC721 promote compatibility. Global reach. Ethereum's decentralized nature allows access worldwide. Example: a gaming platform where players trade virtual assets using Ethereum. Why is this important? Ethereum's versatility supports diverse industries, from gaming to finance. Slide 10. Disadvantages of Ethereum. What are its challenges? Despite its advantages, Ethereum faces significant hurdles. Key points to discuss. High gas fees. Transaction costs can be prohibitive during network congestion. Scalability issues. The network struggles to handle high volumes of transactions efficiently. Energy consumption. Ethereum's power consensus is energy intensive, though transitioning to PoS. Smart contract vulnerabilities. Bugs in contracts can lead to financial losses. Slow transactions. Compared to newer blockchains, Ethereum's transaction speed is relatively low. Example, during a popular NFT drop, gas fees skyrocketed, making participation expensive. Why is this important? Understanding these limitations is essential for evaluating Ethereum's suitability for specific projects. Slide 11. Ripple advantages. Why use Ripple? Ripple's unique features make it ideal for financial applications. Key points to highlight. Fast transactions, settles payments in seconds. Low costs. Transaction fees are minimal compared to traditional banking. Interoperability. Works with various currencies and systems. Enterprise focus. Tailored for financial institutions. Reliable infrastructure. Uses a consensus protocol for efficient operation. Example. A bank using Ripple to streamline cross-border payments. Why is this important? Ripple's efficiency revolutionizes global payment systems. Slide 12. Disadvantages of Ripple and Corda. Ripple. 1. Centralization concerns. Ripple has been criticized for lacking decentralization, which is a fundamental principle of blockchain technology. Unlike Bitcoin or Ethereum, where no single entity has control, Ripple's network is largely governed by Ripple Labs, making it less trustless and open. Example. Critics argue that Ripple's consensus mechanism and control over validator nodes reduce its credibility as a decentralized system. 2. Regulatory issues. Ripple faces significant legal challenges, particularly around its native token, XRP. Regulatory bodies like the SEC, Securities and Exchange Commission, have questioned whether XRP is a security, leading to uncertainty. Explanation. This has created a barrier to adoption, as institutions are hesitant to engage with a token under regulatory scrutiny. 3. Limited use cases. Ripple is primarily focused on financial services, especially cross-border payments and remittances. While this specialization can be advantageous, it limits Ripple's applicability in other industries. Example, unlike Ethereum, which supports a wide range of decentralized applications, DApps, Ripple's use is largely confined to financial transactions. 4. Dependence on institutions. Ripple's success heavily depends on adoption by banks and financial institutions. Without their participation, the network's functionality and relevance diminish significantly. Significance. This reliance can make Ripple vulnerable to shifts in banking trends or preferences. 5. Pre-mined token. The entire supply of XRP was pre-issued by Ripple Labs, raising concerns about fairness and central control. Critics argue that this approach is inconsistent with the ethos of blockchain, which often emphasizes equitable distribution through mining or staking. Example, the pre-mined nature of XRP has led to skepticism from blockchain purists who value decentralization and transparency. Corda. 1. Complex deployment. Corda's deployment often requires enterprise-level expertise, making it less accessible for smaller organizations or individual developers. Explanation. Setting up and maintaining a Corda network demands significant technical know-how and resources, which can be a barrier to entry. 2. Limited decentralization. Corda is designed as a permissioned blockchain, focusing on controlled access rather than open participation. While this enhances security and privacy, it sacrifices the decentralization that public blockchains offer. Significance. This trade-off makes Corda more suitable for regulated industries like finance but less appealing for broader, decentralized applications. 3. Costly implementation. Building and running a Corda network requires substantial financial investment in infrastructure, licensing, and maintenance. This makes it a viable solution primarily for large enterprises with the resources to support it. Example: smaller businesses may struggle to justify the costs of implementing Corda compared to other blockchain options. 4. Privacy trade-offs. While Corda emphasizes data privacy, this focus can sometimes hinder auditability and transparency. Balancing privacy with compliance is a challenge, especially in regulated environments. Explanation: over-prioritizing privacy might limit the ability of external auditors to verify transactions effectively. 5. Niche use cases. Corda's design targets specific industries like banking, insurance, and supply chain, limiting its versatility compared to more general-purpose blockchains like Ethereum. Significance: this specialization means it's not ideal for developers looking to build diverse applications. Example: Ripple's ongoing legal battles with the SEC demonstrate how regulatory challenges can hinder adoption, even for a technologically advanced platform. Significance: both Ripple and Corda showcase the trade-offs involved in designing enterprise-grade blockchain solutions. While they excel in specific areas like privacy, efficiency, and targeted use cases, their limitations highlight the challenges of balancing innovation with practicality.